Hello, today we will talk about convolutional neural networks. I am Tiffany Williams, and let's jump in. So, what exactly are neural networks? So, neural networks actually mimic the functionality of the human brain. So, just as the brain has nodes that carry things and process everything, that's exactly what neural networks do. So, we use what's called perceptrons to carry nodes of data through multiple layers of the network. Those nodes are assigned weights. There's sum, and that sum is used to create a prediction or an output. So, specifically, convolutional neural networks are a little special. So, this model is used to process and analyze visual data. You can use them for things like image classification, for labeling images, object detection, segmentation of data or pixelated images, or even handwriting recognition. Yep, when you're using your iPads and you're writing your things in your own handwriting and it transposes it. Yep, this is the technology behind it. And some of the libraries that's used is actually TensorFlow and Keras. I have used those, PyTorch, and OpenCV. So, convolutional neural networks are broken down into what we call layers. There's multiple layers. This is what makes it so interesting because it goes through multiple layers to utilize different functions to come out with the actual output. The input layer is basically what we put in the image, and it is pixelated. Yes, you've heard the right word, pixelated. This is exactly what we use to break that network down, break the image down, and into layers where it can be analyzed in smaller portions. In that, we use the convolutional layer, which within those pixels, the features are identified. So that's if it has edges or curves, or if there's particular colors associated with it. From that layer, it goes into the activation layer. This determines what gets passed down through the rest of the networks. And then we'll pull those features together to get a fully connected layer that combines all of the relevant features to get us the output. But let's take a deeper look into those different layers. So that convolutional layer, this is what we call feature extraction. And so again, when I say pixelated, I mean we take a small grid called a filter or a kernel and we slide it over the actual pixels or that small portion of the image piece by piece. And this way we can kind of use the pixels to determine what features are in each of those areas. We use what's called a feature map based on what the kernel or the filter is seeing in each of those pixels. This feature map is basically a formula where we take the input of the pixels times the filter values. So the filter values could be 0, 1, -1 based on the options of whether there's a curved line or a straight line or no line. Those could be options within the pixels. And so we use this formula to create a matrix and it gives it a value. And those values will be used later in other layers so that we can determine what features it actually has. So the feature maps just basically represent what learned characteristics are in each of those pixels. Next, we have the activation layer. So this layer is where we kind of start to filter down those numbers that were calculated in the feature map, sorry. This is where we start to reduce that down to the most relevant ones and remove the negative numbers because usually the negative numbers mean it's not captured, the feature isn't captured. And so we want to make sure that we're moving along the relevant parts of the feature to the next layer, which is pooling. And this is where we keep all of the relevant features. So this is where we determine, yes, they have curved lines. Yes, there are circles, and yes, it's tall, or no, it's not tall. Those are the type things that are used in the pooling layer. And there's two types of pooling. We can use max pooling or average pooling. So again, remember that feature map formula that we used? That feature map score is within a matrix, and max pooling actually will take the maximum value out of that matrix, whereas average pooling will average the scores around a particular area. So there are two different options that we can use based on the clarity that we want to generate within the model. But from pooling, we will then go on to the fully connected layer. At the fully connected layer, this is where all of the features are combined together, and it creates the output or the prediction based on the network model. But there are some things, I made it sound very simple. There are a ton of things that go on behind the scenes. And some of those things, first is back propagation. So this is where we compare the predicted output to the actual output or actual image. We can calculate the error and adjust the filter weights to minimize the error. And this is done through multiple iterations. So if you look to the right, you will see a flowchart that contains all of the layers that we have previously talked about: convolution, activation, pooling, output. And you'll see the blue lines are what we call a forward pass. So the data flows through and makes it predictions. The yellow or orange lines are what we would call a backward pass. So in a backward pass, remember we said there are weights and things associated with it. When we go through the backward pass, we're actually trying to update those weights so we can get the lowest loss function score possible. Because the loss function is the measure of how far the network's predictions are from the actual target values. So this takes place during the back propagation. And we use this to adjust the filter weights. So we'll run it through one time, get those filter weights and the loss function score. One key thing about the loss function score is we want it to be low, because the lower it is, that means the more accurate the network is performing. The formula for to the right is actually the mean squared errors function. This is a loss function that we can use, and it is basically summing the difference of the predicted value minus the actual value and squaring it, and that'll give us our loss function. So again, we want the loss function score to be as low as possible, because that means our network is performing accurately. Some things to keep in mind, though, are security risk. There are things that we have to be not mindful of, such as model theft. And model theft is an interesting one because hackers or people who have modeling knowledge don't have to necessarily get their hands on the network, on the model itself. They can keep replicating and trying to rebuild it until it performs similar to the actual model. So there are things that have to be put in place to mitigate that, such as an organization can implement a query rate limit to stop people from running it so many times, to kind of figure out how it's working behind the scenes, or some authentication can be put in place, or even restrict unauthorized access to kind of protect the model. Also, there's a such thing as adversarial attacks. So these are small, very small changes that's input into the images to fool the convolutional neural network into making incorrect predictions. For example, altering a few pixels of a stop sign to make it seem like it's a speed limit sign. So some things to mitigate that is actually training on identifying that, and training the model to identify when images have actually been a little altered. And we can't forget the ethics behind it all. So, one of the ethical issues could be Previously, years ago, there was a whole article written because it was said that Target had predicted when someone was pregnant based on their shopping habits and behaviors and things they were searching for. And that can impose a very ethical issue because it could basically violate someone's dignity and their respect. And based on, biblical truths, you want to kind of look in Genesis and it talks about that. But we don't want to cause emotional harm or any discrimination to anyone based on predictive modeling. So we have to be mindful of that, as well as Hewlett Packard was a few years ago, I think in 2013, using predictive modeling to predict whether or not employees were looking to resign or leave the company. And again, that can be a little predatory. It can impose fear and it can cause anxiety and it can impose on people's free will to, leave a job. So we have to also keep in mind the ethics behind neural networks as well. So, some key takeaways are neural networks are specialized networks used to analyze images in multiple layers for things such as facial recognition, self driving cars, and handwriting detection. There are some core levels or layers associated with neural networks: convolution, activation, pooling, and fully connected layers. They all work together to extract features and classify images. And we must remember that this is not just a one time thing. There are iterative processes that go into this because we want that loss function score to be as low as possible. I hope you've enjoyed this summary of convolutional neural networks. If you would like to read more into my sources, here is the references that I use. I hope you have enjoyed. Have a great one.